Welcome everyone to this mapping and inspection of construction sites with unmanned aerial vehicles. They are commonly called UAVs. I wanted to give you the full denomination before we start, but during the whole presentation, we'll use the term UAV. Let me just give you a little bit of background. My name is Diane Méchalon. I'm Business Development Manager UAV by Topcon Position in Europe. I live in France, as you probably can tell from my accent. I've been involved in the UAV world since straight out of business school because I wanted to work in an innovative environment, and I've been lucky enough to see this world from the beginning and how you can transition from introducing something really innovative into being somewhat common in the construction industry. And that's a little bit the key message I wanted to show you with this presentation. I want to walk you through this transition to from innovation to almost commoditization. I'm with Tasso from Professional Services by Topcon Europe Positioning, and he'll be the one illustrating my presentation by a real use case that hopefully will help you better understand what we're talking about. The agenda will be as followed. We'll be talking about mapping and inspection of construction sites using UAV. The first part will be around mapping of construction sites. We'll show you how it works in practical, and then we'll discuss the benefits of changing the ways of traditional means towards UAV, those mainly being for productivity and better data sets. We'll show you the workflow that it induces, and then we'll conclude describing the process of planning and analyzing aerial data. And then Tasso will finish by a user case. So I'm not sure how you're familiar with UAV in the construction workspace. So I thought I'll show you a video that I will talk over to show you what an acquisition look like. So I'll start around here. This is a promotional video, but it shows an operator arriving on the ground to do a mapping with UAV, and is building the drone. As you can see, this drone is what we call a fixed wing. It's shaped like a plane. And usually to do mapping in construction sites, you will be building an automated flight plan to make sure that your acquisition is consistent over the whole area that you want to survey. So he's building his flight plan and he's sending it to the UAV in order to be executed. So that's what you're seeing on the video. And then he's doing the pre-flight checks. So he's been trained to build his planning and to do the check, and is launching the UAV for takeoff. Easy as that. And then it's automated. The UAV will follow the flight plan that's been implemented, and that's what you can see here. It's the software that is coming along with the UAV and is able to check that the acquisition is running smoothly. What is interesting about this drone is that it's resisting well against strong winds. And what I like also about this software is how intelligent it is into building the branches and following the branches to make sure it maximizes the flight plan and the flight time of the drone. This drone has a relatively long flight time, which is interesting. What you can see also on the software is the picture being taken, what they represent on the ground. And when the UAV finishes, is preparing itself for a landing. This is a semi-automated landing, and this is where the pilot supervises the landing. And I'll stop the video right after the landing so that you can see how it looks like. But yeah, though we've not been able to give you a real demonstration of mapping with UAV, this video, I think, gives you a nice representation of what it looks like. So it's landing on the belly. Okay, I'll stop the video. So this was the acquisition part, but the real work almost starts now, because most of the work is about processing the data to make sure that they are usable for the construction site in order to take decision. Because the reason why they're doing this is so that they can periodically survey the construction site and do comparison, check things, take decisions. So it's really important, the data set they are building doing that. What I wanted to you about is when you're using traditional means of surveying, the problem is that you have two problems actually: the difficulty to access some areas and also the exhaustivity of your data set. And that's something that is really, really interesting with UAV. You can access areas that otherwise would have been difficult to access, and you can have a much more exhaustive data set, survey the whole construction site, whereas sometimes you would only have sampled certain area, for example. So the accuracy is better. You don't need, with this type of UAV, for example, ground control points, so you're saving a lot of time because the acquisition is IO. And you have the data that you're getting out of the drone and putting into the post-processing software are actually pictures that are come along with the GPS tag and also the timing at where the pictures have been taken. So you're really resolving the problems of access and accuracy, exhaustivity of traditional means using UAV. So the reason why you're doing that mostly is because it's less costly and it saves you a lot of time, meaning that in some construction you'll be forced with traditional means to stop what you're doing in order to access to actually serve it. Whereas you can fly while the construction site is still in function. With traditional means, you'll probably need some additional approval in terms of security, danger, and everything. With UAV, you might not need that. You might need other approvals, depending on the regulation in your country, in order to be able to fly a UAV. But when you are investing into this process, that's something also you're trained to do and that you implement into your processes, meaning how to request permission to fly. And you'll be having like a complete overview of your site, which you probably don't have otherwise. And it will take you a fraction of the time that it will usually take you with traditional means, meaning that you can do it more often, for example. So it's really interesting, and it's really changing the way you're having your views with data and taking decisions. Of course, you can be more productive in your decision making. What I was mentioning is that this UAV doesn't require you to have control points on the ground that will help you position the model created post processing. So that's also one thing to consider. That will save you time. You can do everything with the UAV and the post processing. The types of outcome you can have are various. You can see one of it on this picture. You can create reality meshes, point cloud, elevation model, auto photos, and it really gives a new scale to your project to be able to have so much data. And actually, it's not so much about having a lot of data; it's having the right data to take decision, and that's what building the right work is about. And you'll be having all the pictures taken by the drones, and it will be quick. So this application doing mapping with UAV, it's one of the most major application with UAV. The second one being inspection, and actually they're really complementary because when you're doing mapping on a construction site, you have actually invested into training people in building processes. So you might as well have the dimension of doing inspection, for example, of buildings on your construction site. And it's a similar workflow actually, where inspection would be more manual. For example, you want to survey a building, you want to check the roof, and you'll be flying exactly towards where you want to survey. It can be a one-man job with the UAV, the pilot takes picture, or you can even involve someone as an inspector, and the pilot can concentrate on flying the drone over the area and decide with the inspector where to take pictures to make decision. So it's really about integrating this what used to be an innovation into your workflow, transitioning towards photogrammetry, building the right acquisition, having in mind the needs that you're trying to fulfill, having the right tools and train people to do the post-processing. It's really an end-to-end solution coming from the need to solve a problem towards the actual delivery that helps you make decision on the ground, either around mapping or around maintenance, repair with inspection. So it really simplifies the process. And one of the main thing of implementing new ways of doing things is it has to communicate with other areas, either mapping, inspection, and integrate really in the workflow. And I wanted to show you another synergy of having UAV on the construction site. This being monitoring. When you're doing inspections, for example, you'll be having yourself in an inspection workflow, meaning that you'll inspect, you'll create your report, and that's what was shown in the previous slide. The person that you saw was actually looking at the model, detecting defects, looking at the picture corresponding, and building a report to give to the guy on the ground to do maintenance and repair. And that's the inspection workflow. You inspect, you create a report, and you go either in repair or maintenance mode, and you repeat. And sometimes the better decision would be not to wait for the next inspection, but to go into another workflow, meaning that you'll be leaving, for example, monitoring sensors on, I don't know, a crack that you want to survey or something like that. And it builds a new workflow where you can monitor and decide whether you want to go into repair, into maintenance, or wait for the next inspection cycle. So it's really an integrated workflow. And to illustrate that, I'll leave the floor to Tess so that he will show you a real case example of what I've just described.
Yes, thank you, Dan. Let me share my screen to give you a short overview of our workflow. The first step of the workflow is, of course, the flight planning. What we use for the Cirrus Pro is this Mavinci desktop software. It gives us a lot of options for the flight planning. I just want to show you quickly how easy it is. Let's say we want to survey this field over here. I simply select the Polygon flight planning tool. I have to draw the polygon by giving in the points which border my area of interest. I tell the software to calculate my flight plan, and there I have already a simple flight plan. The software will tell me straight away how long the flight time is, so that's almost 8 minutes for this small flight plan. The plane will fly 7 kilometers and take 167 pictures. Let's delete this one. Just hide it. Now for the user case that we are going to show, we will survey this road over here. This is actually a real project that we did a while ago. For surveying the roads, we have another flight planning tool, which is called the corridor mapping, where I only have to tell the software where the road is going, and it will automatically create a flight plan on this corridor. Now, of course, I can adjust it a little bit, give it a bigger width or smaller one, and I can adjust a minimum amount of lines that the plane is going to fly. Now, this minimum amount of lines we need to achieve a certain overlap that allows us to calculate the 3D model out of the pictures. Once you've created the flight plan and you're outdoors, you can just, as shown in the video, you can simply upload the flight plan to the UAV itself, and it will fully automatically do the flight. After the flight, we take the pictures into Mavinci Desktop. Let me show you that as well. So this is a different project, but just to give an illustration of how that looks, we bring the pictures into Mavinci Desktop, and as you can see, these are still single pictures, but with a lot of overlap in there. All those things that you see popping up, those are all single pictures. Now, this is, of course, this is not a real product yet. We need to take a couple of more steps to process this into a real product. To do so, we need a different software. Mavinci Desktop allows us to export straight to a couple of common processing softwares that are commonly used for processing UAV data. I will show you Context Capture, Topcon's Context Capture software. Exporting is really easy, as you can see. I just go into the post-processing menu and I can export straight away to Context Capture. Let me change the screen to Context Capture. So what it will do after I export it to Context Capture is it will automatically create a project with my data in here. It will look like this, where all the pictures are brought into software. As you can see, they all have a position, and not only a position, they are already geo-referenced. As you can see, we have coordinates over here. Right now they're in WGS84, but I can select any regional system as well, of course. Now they are still single pictures. They have a coordinate, but they are still single pictures, which is not what we want. We want to process them. So the next step will be to calculate an error triangulation. So in the error triangulation, the software will automatically calculate 3D coordinates from the pictures. Because all the pictures have a lot of overlap, the software is able to do so. So that will look like this. What we see over here is what we call tie points. So those are used before our next step. This is the result from the error triangulation. And in the next step, we can really build a prediction. So in Context Capture, you have a couple of possibilities to build production, a 3D mesh, a point cloud, or an orthophoto, for example. Now, of course, you can use all or most industry standard extensions or formats to build production. So for the user case, I've created a point cloud for the road project that we created a flight plan for in the first step. To show you, I will go to another software. So this is from the actual flight that we did in this road project. This is the point cloud from my data from the Cirrus Pro. As you can see, I brought it into Magnet Collage, one of Topcon's software, where I can review the point cloud. I can do a couple of analysis. I can do, for example, volume calculation. From here, I can generate DEMs, TINs, those kind of things. But one of the advantages as well from this software is that I can bring data from multiple sensors together in the same workspace. So what we see here is just the point cloud created from the UAV data, but we did some more. In the area of this bridge, we also did some scans with a static laser scanner. So if I turn that on, you can see now there are some more details also on the side of the bridge, because of course the UAV, it takes a lot of pictures from above, but the side of the bridge will be a little bit difficult. So we've added a static laser scanner from there. And also we have been driving around with a mobile laser scanner. So process that as well. And I can turn it on and you can see it's the full road project that's been there. And of course, it's all geo-referenced. As you can see in my smaller screen, it just fits nicely on the map. So now this full data set is available for further steps. I can do some simple analysis in here, or I can bring it into another software that may be available. Right, so that was a brief overview of the UAV workflow in the case of this road project. And now back to Diane.
Thank you, Tasso. I just wanted to conclude here by saying to you that I hope we have shown you how interesting it's to go from introducing something really innovative that that challenges the way people are doing things, and actually finding ways to create more synergies so that the application becomes matures and that it becomes really common to use on construction sites. So thank you very much for your attendance, and we'll be staying online for a little while in order to answer some of your questions if you have some.